with this, I start this lecture on minor technologies. I put minor in quotation marks because they are very important, all of them. But there are technologies on which we don't always have too many sources. So, and I thought I would club them together so that this completes our horizon of technologies. I should mention that the last week, the week after next week, we will have 3 lectures on archaeometallurgy. So more details through the Google Classroom on this. So now, let me begin this quick survey. Since I've clubbed, as you will see, 5, 6 technologies. I will not go very deeply into any of them. It is more of a survey, but it will enrich our knowledge of technologies in ancient India. So one technology which is not too often spoken of, though of course nowadays it is becoming a little of a burning issue in India, is sanitation. And sanitation is something that it's only in the last few decades we feel more and more concerned with, but ancient India was also concerned with, because the moment you have cities with thousands of people packed together, living together closely, you have sanitation problems. So if you don't do anything, you're going to have spread of diseases, unhygienic conditions, etc., which unfortunately remains the case in some of our Indian cities, though there is some progress, nevertheless not up to the mark. It so happens that the Harappans were very concerned with sanitation to a degree which was not expected in those times. I remind you, we are now in the 3rd millennium BC, 4,500 years ago. And if you look at the cities of ancient Egypt or ancient Mesopotamia, contemporary with the Indus or Harappan civilization, you will find that only very small parts of those cities had sanitation, usually where the king or the pharaoh in Egypt lived. The rest of the cities did not particularly have a complete integrated sanitation model. And what I mean by that, it is not just this great bath of Mohenjo-daro which you see here, beautifully constructed with baked bricks. And it had a waterproofing, 2 waterproofing layers over the baked bricks which you see at the bottom, which were so perfectly aligned that the gap between the bricks did not exceed 1 millimeter. But over this, they had a layer of gypsum plaster. Gypsum is a natural mineral with which if you fire it, you can have something close to somewhere between the plaster of Paris and cement. And over this gypsum plaster, they had a layer of natural tar, which is called bitumen technically, and which occurs naturally in Balochistan, which is just nearby. There are natural springs of hot liquid bitumen, and it will, of course, somewhat solidify, not fully solidify, when it cools down. So they harvested that and they laid it over the gypsum plaster and over the bricks. So this is how they were able to waterproof this great bath, whose purpose is not yet absolutely settled. Archaeologists disagree whether this was the pleasure bath of the royalty of Mohenjo-daro or whether it was a ritual place, somewhat like the temple tanks of classical India. But regardless, there was quite an understanding of hydraulics, because you do not see here, but in one of the rooms, one of these cells here, there is a well. I'll show you the Harappan well in a minute. And this well was used to draw water and fill the tank. And then the tank in this corner, again, not visible on the photo, had a huge drain which was of a man's height and which could be closed by probably a plank of wood. And this was used to regularly empty the tank whenever the water would become dirty. You remember the technical term that Professor Arun Menon attached to these drains, Harappan drains? He showed us some. And do you remember how they were built? Excellent. Corbelled. They are, you know, with layers of bricks that come closer and closer and closer. It's not a true arch. It's a corbelled arch. So this is for the Great Bath, but actually less impressive but more technically challenging is this typical sanitation system of a large residence in Mohenjo-daro. This was all documented by Professor Michel Janssen, a German architect cum archaeologist who spent many, many years at Mohenjo-daro studying all these civic developments, which actually he found quite remarkable. You see, the Harappan civilization does not, at first sight, have very spectacular achievements like the great pyramids of Egypt or the ziggurats of Mesopotamia, or great art pieces of like the Mayans and so on. But it has still very remarkable achievements which are more discrete, and it takes time to understand them, like this one. What you see here is a large house of a trader. There is a well here. This well is a private well. There were approximately 700 wells in Mohenjo-daro. And it is estimated by Professor Michel Janssen that the average distance a Mohenjo-daro citizen had to walk to get water was 35 meters. This is what he calculated, which means that water was plentifully available to the Mohenjo-daro citizen. That itself is a great achievement. It's not there in all our modern Indian cities. You still have people having to walk half a kilometer, 1 kilometer to get water, or more sometimes. So these wells, I will discuss the well technology in a moment. Here is private. About half of the wells in Mohenjo-daro were private and half were public in streets. Why is a matter of debate. Of course, having a private well secures the cleanliness of the water. You're sure that nobody's going to dump anything in the well. You have control over the drawing of water and so on. This might be one pragmatic reason. There could be other reasons like concepts of pollution. This has been discussed by archaeologists. Anyway, whatever the reason may be, this house is wealthy enough to afford its own private well. And then what you see here is what we call a bathroom, or more precisely a bathing platform. So you remember from your school textbooks that every house in Mohenjo-daro had a bathroom. It's almost true. Almost every house had a bathing platform. That itself is a remarkable achievement. Again, make a census of any old city in India, and I don't think you will find more than 2/3 of houses on average, or maybe half, having a bathroom. So that is remarkable. And the slopes of the bathing platforms was always carefully calculated so that the water would flow out by the sheer slope. And here you see a drain. This drain is inside the house. Of course, it is excavated here. It will not be visible during the time of the residence of the house. And it will be covered by stone slabs or some planks or something. And then it also has a slope. Now, this is a remarkable thing that Michel Janssen measured slopes of drains all over Mohenjo-daro. And he found a consistent slope of 1 to 2 centimeter per meter. So each meter, you get a slope of 1 to 2 centimeters. And that ensures that the water will flow. Now, it may look very simple to say that, but how do you establish a consistent slope all over a huge city like Mohenjo-daro, which possibly had 50 to 70,000 inhabitants? How do you do that? You can do that strictly with one condition. Can you identify? It's very, very simple, just common sense. You can ensure consistent slopes of all your drains all over the city only if you have any idea? It's extremely simple. Only if you have planned the whole sanitation system before you build the city. If you have not done it, like I lived in Coimbatore for many years, Coimbatore had no drainage system because like many Indian cities, it was just an outgrown village. It was a village that had grown into a town that grew into a city. There was no sanitation system. So they started building. They said, now we will have a drainage system. But how do you control the slope? You can't move the houses up and down. You see? It's too late. So you do drains, and they have the slope that they managed to have. And of course, when it rains, all the drains will overflow, because only a small part of the water will actually flow away. So the Harappans were superior in some way to our modern urban planners, because they integrated this by having blocks of houses built on separate individual platforms of bricks, and the height of these platforms was planned in advance so that all the drainage would work efficiently. This itself is unique in the ancient world. So you see now that our drain here passes below this boundary wall. We are in a street here, small street, more like a lane, and you can see a gentle curve. The drain is completely made of baked bricks, fire bricks. All the millions and millions of bricks in Mohenjo-daro were used to create this drainage system. Because if you're going to use just sun-dried bricks, they will disintegrate fast in contact with the water. And you see the slope continuing, and then you see this kind of square box. Anybody can suggest a name for it? It's very simple. It is called a sump. This is a sump. And what is the role? Can you just tell me? Again, use just common sense. What is the function of this sump? Why should you have a sump? If you don't have it, the water will flow. Or will it? Yes, exactly. If there are any solid materials in your water, and there will be after using the bathroom, then this sump, when the water falls in the sump, it will slow down. And any water that slows down will drop its sediments or solid matter. So this is used to collect that. And this carries another message. If you have a sump that collects solid waste, it means that there are people who will go and remove them. Because we know that the sanitation system worked for centuries together in Mohenjo-daro, possibly 6 or 7 centuries. And therefore, there was a very efficient municipal force, municipal organization. Though we know nothing about it, we don't have texts, but we know from archaeological evidence that there was a strong administration of the city that controlled this quite efficiently. And then you see that the drain continues, and these will join into bigger drains that ultimately will take all these used waters out of the city. So this is sanitation technology. We have some examples of it in later classical India. Some of the Gangetic cities will have, but not completely integrated all over the city. I'm not aware of any city of later classical India that has such a complete sanitation system. There will be a few drains here and there for the better areas, better homes, but it will not be planned on that scale. So this is a remarkable achievement. Now this is the Harappan well I was telling you about, which we saw in this private home. It is a technological innovation, quite remarkable, because do you notice the shape of the bricks? And I'll request the students who had maybe a course with me earlier to keep silent. I want the students who do not know to try to guess. So anything special about the shape of the bricks? Are they usual? Yes, so that is called, what is that shape? Trapezoid shape, exactly. Why should you build a well with trapezoid shape? Now, I should give you a clue, because usually I get all the wrong answers first, so let us save time. I'll give you a big clue. We are in Mohenjo-daro, very close to the Indus. The water table is very high. Indus is a mighty river. that will create a lot of underground infiltrations. And sometimes it will go into spate also and flood the whole region, but that's another issue. So why would you want to have trapezoid? Why not rectangular bricks? What will happen if you have rectangular bricks? And surely the Harappans initially started trying out with rectangular bricks. And they found that it was not working. Why? Okay, if anybody else knows the answer. Saurabh? Exactly. So Saurabh remembers from another course. You see, because you will have in some seasons at least, let me say the monsoon, you will have a lot of underground infiltrations into the well. If there will be pressure from the surrounding soil on the well, and if you use rectangular bricks, you will find these bricks pushed inside and falling at some point. Some of them will start falling inside the well, and ultimately your whole structure is jeopardized, it's compromised, and one day the well will collapse, which is what happens. What happened with Roman-built wells 2,000 years later. Romans built square wells, usually with stones, square stones. And they were constantly struggling with this problem that after a while the structure gets weakened, some stones fall inside, and one day the whole well collapses, and you simply have to rebuild it. So they never found this solution which Harappans had found 2,000 years earlier, which is that if you use trapezoid bricks, the whole well structure locks together, and it can bear a tremendous amount of pressure, and it will not collapse inward. This is a tremendous invention. Now, do you remember what Professor Arun Menon said? Actually, we had a discussion with him long back, and I observed that this is nothing but the true arch, except that it is horizontal. It's not vertical. The true arch, vertical true arch, I will not spend too much time, but this is exactly what the true arch does. These are trapezoid bricks locking together and being able to bear a lot of load. But for some reason, Harappans did not have the thought of turning this horizontal arch into a vertical arch. That is one thing they didn't do. It was done much later in India. But even then, this invention is quite remarkable and shows the kind of inventiveness they were capable of. Now, water lifting mechanisms, which we heard Srinidhi giving us a small presentation on this. In fact, this is one of the very earliest water lifting mechanisms in India. Srinidhi quoted John Marshall, assuming that there were water lifting mechanisms like wheels in the Harappan civilization. Actually, there is no such evidence. It might have been, but it's purely speculation. However, this is Dholavira, the huge well on the castle. And here we have a very, very simple, basic, rudimentary, but effective water lifting mechanism, which is evidenced by this slab. If you ever visit Dholavira, don't miss this. This is a huge stone well. The stones, by the way, are not trapezoid. And there's a very simple reason why. Because Dholavira is a very dry climate. Unlike Mohenjo-daro, there is no river. There are no powerful underground infiltrations. Therefore, they don't have to cope with this problem of resisting, surrounding soil pressure. And therefore, they did not bother using trapezoid stone. The regular stones would do. So here, what you see is a slab of stone where probably people stood to draw water, but see those grooves. I don't know if you are all well placed to see those grooves on the edge of the slab, which Dr. Bisht, who directed the excavations at Dholavira, has explained are definitely the marks of ropes going up and down. Ropes passing up and down again and again and again. And leaving those grooves on the edge. And now those ropes, you might say, well, maybe people drawing water, but if people draw water, they're going to stand on the edge. The rope is not going to rub against, probably not going to rub against the. So this, in his opinion, was created by a pair of bullocks walking away, and he has reconstituted the whole, because the place has been considerably modified, the whole way the bullocks were pulling probably a big pouch of leather, because a pot might have easily broken, some big leather bag which would draw up water, and which they would then draw all the way to the slab, and from the slab there was actually a drain going and to fill 2 nearby tanks, and probably this was done by a pair of bullocks. So this might be one of the very earliest evidences. But then, if we jump in time, we come to this Persian wheel, which you see there hanging over a huge well, and with the pair of bullocks. Let me show you a better photo. But before, see, there was a kind of a convention that this wheel had come to India with the Persians, and therefore it has some names like Shakya, Rahat, I believe, is also partly Persian, partly Urdu, etc. All these names are used. Araghata is a Sanskrit name which appears in some texts. Kumaraswamy, the great art critic of India, disagreed that the Persian wheel was of Persian origin. He found enough evidence in Indian texts and some representations that it could very well, it pre-existed the Persian presence in India. So whatever the exact origin may be, the mechanism is that you simply have a wheel with containers. They might be buckets, they could be pots, they can be in any material. Wood, buckets of wood typically were used for a long time because pots can easily break. On the right you can see a more modern, still used Persian wheel in a village of Rajasthan. Then they have used metal pots, and basically all you need to do is turn the wheel, obviously. And this can be done by a series of mechanisms, especially typically to transfer the vertical motion of the wheel into a horizontal wheel. This is done by an exchange of gears, and the horizontal wheel will then be drawn up and down again by a pair of bullocks. So this is fairly simple, and you can see on the left the complete wheel dipping into the water of the well at the bottom. It's simple, efficient, can go to reasonably great depths, and this has served well in the countryside of India. The other day I was in Jodhpur, and I took this photo of Persian wheel on the edge of course the bottom part is gone, on the edge of the fort, at the top of the fortifications, because forts, you know, in India always had some issues of challenges, I should say, of water supply. They usually had very extensive water harvesting systems, because forts, if you besiege a fort, you might starve people, but if there's no water, then the issue will be very quickly resolved. You can hold out for some time without food or with limited food, but without water you can't. So they took great care of water harvesting, and ultimately there was always a pond or two somewhere, sometimes underground reservoirs, from where this stored water would be pumped up by means of such Persian wheels. Let us move to transport. And well, there would be a lot to say, but as I said, I am not going to go very, very deeply into any of these. But still, transport in India, India is a big land. And very early on, humans, especially when the urban stages of civilizations came about, but even before, have tried to develop more efficient transport system than simply putting a load on a donkey's back, which is a form of transport, and it's still used in India. So that We should not despise it, but it's not extremely efficient. And therefore, the wheeled cart is in all civilizations one of the breakthroughs which usually takes place in the 4th millennium BC or so. In India, it will correspond to the early Harappan phase before the development of cities. In the 3rd millennium, about 1,000 years earlier, you begin to see those carts appearing. Luckily, we have these little toys. This is, you see the scale, 10 centimeters on the photo. So this is just a miniature representation. And the Harappans were very fond of making these toy carts, very probably to keep their children amused. I mean, this is the reasonable assumption. And you can see that the wheels are full. You can see that there are 2 wheels. There are 2 bullocks. There's a central shaft, which will have a perpendicular shaft to which the bullocks will be yoked. So it's a simple, you might say primitive kind of cart, but not so primitive, because when the archaeologists documented this cart in Mohenjo-daro and Harappa initially, they realized that in Sindh and Punjab, where they were excavating, the very same carts with very, very few differences were used. Not only that, they were able, in Harappa in particular, they found a street where the mark of the wheels, which are called the ruts, were still embedded in the street. And they measured the width of the 2 wheels, and they found that the width was exactly the width of the carts used in Sindh, exactly at the same time, which would be in the 1930s, 1940s, when they were excavating. So even the width between the 2 wheels had not changed. So therefore, it must have been found efficient enough. There's a small controversy about whether the Harappans were aware of the spoked wheel, the wheel with spokes, which will be a great technical advance because it allows you to have much lighter wheels than the full wheel. This is not really resolved. Professor Bibilal and other archaeologists, including Dr. Bisht, are of the opinion that they might have known the spoked wheels because, as you can see on the right, there are terracotta miniature wheels represented with raised radiating kind of spokes, and also painted ones at the bottom. However, there is no actual relic. But at the same time, wood has not been preserved in the Indus civilization at all, except for a few fibers here and there. So therefore, if they did exist, they would not be expected to be preserved. So anyway, we can keep this with a question mark as I did on the slide and move on. And then, before we see some innovations in the carts, I want to show you the kind of road network. Major roads, because of course there would be an infinite number of smaller roads which developed in India in what we call the early historical period, which could be, say, about from 600 BC, 700 BC onward. And what you see is a network of roads here on the Indo-Gangetic plains. This whole axis is known as the Indo-Gangetic plain. And from very early on, you see, if you wanted to go from Taxila is here, to the Ganges region, you would use those roads. Even in the Ramayana, if you remember the story, I think it is Bharata, who is cold, and he was somewhere in the Taxila region, and he has to reach urgently because of the crisis, you know, the whole story of Rama being told to go on in exile, etc. And he has to reach Ayodhya, which is here, and this is the road he would be using. So these roads were well known, and they were called Uttarapatha. And they are described in the literature, in the Buddhist texts. This term is used extensively, and this is not one road, but several roads. And very interestingly, when the British constructed what they call the Grand Trunk Road, which is now, by the way, integrated in the Golden Quadrilateral. They did nothing but to use this Grand Trunk Road was precisely this axis, the same, because well, it was so convenient. Now, what is this one? Can you guess the name in the ancient literature of this road, which goes all the way to the south? If the other is Uttarapata, this one is going to be Dakshinapata, exactly. And this is how Ashoka, in his edicts, calls it himself when he describes the southern regions. Briefly, he mentions the term Dakshinapata. So anyway, these were big axes, but again, there were many, many other roads, and they were the trading routes of India's internal trade. We often speak of India's external trade. We forget sometimes that India's internal trade was very vibrant, and goods were traveling all over the place. Not only goods, but raw materials before the goods. Yes? As I said, this is the early historical period. So starting from about 600 BC, when the first cities after the Harappan civilization had disintegrated, the first cities appear about 700 BC or so. Well, there's a bit, there are scholars who dispute that nowadays, but to be conservative, this is the date that is established, and this is known as the early historical period, where you have cities appearing, the iron technology comes, which we'll discuss later in the course. Harappans were in the Bronze Age. It was only copper bronze technology. Now we will have iron. We will have a lot of warfare. We will have a lot of literature. We will have religions like, the Vedic religion, Jainism, Buddhism, many other sects appearing, a lot of literature and so on, the arts. So there's a completely new development taking place. Yes. So whatever few archaeological remains of ancient roads, and recently some were discovered in Uttar Pradesh. I remember seeing a paper on this at BHU. Whatever remains have come to light. The roads were pretty broad, but we have widths of roads being mentioned in the text, but they are, like Arthashastra mentions, several types of roads. The small lanes in the city, the bigger streets where two cars can cross, and then the royal streets, which will be much wider. Whether this was actually executed in practice is a bit hard to say. But some roads have been measured here and there, rather streets in cities. Actual roads outside the cities, very, very few have been measured. But yes, they would have been broad enough to accommodate at least two carts crossing each other. So, yes?
They were constructed, these roads were constructed, or they were like just the route?
The exact origin is often unknown. Lots of things have to be moved about. Armies have to be moved about for warfare, and this is the time in early historical where we will have a lot of warfare between all these empires appearing and disappearing and so on. You have to move about for trade. You have sometimes monks moving about. For example, Jain and Buddhist monks were very, very keen to travel to South India very early on. So all these movements mean that it's difficult to say who built these roads. They were probably much older, smaller communication paths which were broadened and for most of them, especially this Uttarapata. It must have been much older than that. So there are all kinds of transport. We will come, of course, we'll come back to the bullock cart, but here you can see how various animals were used for transport. The elephant, but this was not for the commoner, of course. This was for either parts of an army or for the royal family, and the camel also in North India. So these are drawings taken from various manuscripts or sometimes temples. And then let us come back to the humble bullock cart, which was the dominant form. So there are different types. There are bullock carts of 2 wheels, as you can see here. And this is, after all, pretty close, though it is from Mysore 1800. It is pretty close to the Harappan cart. The wheels are full. You have the central shaft and then the perpendicular shaft where the bullocks are yoked. But then you also have appearing the 4-wheeled cart, which is much more useful to carry like soldiers, which is what you see on the top left. These are frescoes from various temples and from the medieval period, in fact. And even bottom right, I believe we see also soldiers being carried, but also sometimes to carry goods, to carry, for example, stone pillars, heavy items which needed to be transported. This is a more efficient system of transport. So, without going into the intricacies, because we have one French scholar, Jean Deloche, whom I'm quoting here, who's written a very elaborate study of all bullock carts and the types of wheels, how the wheel is connected to the axle, whether the axle rotates or not. There are so many technical issues about the carts, but what he said is, first of all, that road conditions were better in the north than in the south, and at least since Ashoka, in fact before Ashoka, we have these roads developing in the north, and this is the Grand Trunk Road I mentioned. So he finds that it's mostly in the north that the 4-wheeled vehicles were used because the roads were better, but all over the subcontinent, by and large, it was this 2-wheeled cart which was preferred. And this he does not fully understand why it is so. I think it's more a matter of economy and simplicity of construction of the cart. He adds, certain types of vehicles devised during ancient periods were so efficient as a means of transport that they did not undergo any fundamental changes and have indeed survived to the present day. If the traditional bullock cart is still used in most parts of India, it is probably because the farmers, through trial and error over the ages, had already determined the best conditions. And in his recent book on wheeled transport in India, Deloche actually studies all attempts to improve in the 20th century. A lot of engineers came up with ideas to improve the bullock cart. And apart from the use of tires, which certainly makes it much easier for the bullocks to draw the cart, apart from the use of tires, none of the innovations which were proposed has been adopted. They always create some problem. For example, these cars have to move usually in very dusty environments. So this means that if you want to use what do you call these? Sorry, I have a blank. Those ball bearings, they're going to fail very soon because of the dust. So much simpler systems are sometimes more reliable. Now we have a few words on ships, and since Srinidhi has done a little analysis summary of the Yukti Kalpataru, which is one of the great classic texts on ship making, but it's a late text, you see. The point is that this Yukti Kalpataru is about 12th century or so. And we already have ships in India for centuries, in fact millennia. Because here what you see is a Harappan not ship, but boat on the tablet. It's a river boat. Why is it a river boat? Because the bottom is flat. And a flat-bottomed boat or ship is never going to survive long in the sea. So you have this river boat which Harappans were using extensively on the Indus, on probably the Sarasvati, which was the second river of the major river of the Indus civilization. And we know, for example, that pieces of stone pillars manufactured in Dholavira here in Gujarat were found all the way at Harappa in Punjab. And this means shipping this item and taking it upstream the Indus, and then the Ravi River, which is a tributary of the Indus, which is a journey of about 1,500 kilometers. So therefore, yes? Excuse me?
You told that if the bottom is flat, then boat cannot be able to survive in seas.
Yes.
Why? Yes. What is the reason behind it? What is the reason behind it?
Because for the river, for use on the river, this is quite suitable. You see, you don't need a shell which is, with an angle, which is what you need in the sea to stabilize your ship. It's not necessary. If you have a flat bottom boat in the sea, it will not be able to oscillate with the waves. It may remain steady for a while, but if it's get upset, then it's gone. It's finished. So they found later. Now, the question is whether the Harappans themselves had seafaring ships. Before I come to that question. This is a view of the dockyard at Lothal for some of you who have gone. And Dr. S.R. Rao, who had excavated at Lothal, immediately proposed that this huge basin was a dockyard where boats were coming up the Gulf of Khambat or Kambe, and there was a small tributary of the Sabarmati River which at high tide would have allowed these boats to reach Lothal. Conditions have changed. The sea has receded a little bit, a few kilometers since Harappan times. There are some good reasons, though some American archaeologists have disputed this interpretation, but I think there are lots of good reasons, including the vertical walls of this dockyard, the absence of staircase, which you would have normally if it was simply a water reservoir for people to draw water from. You would have a stairway going down, as you have in Dholavira, going down into it, and the presence of sea organisms and seashells found in the bottom of the dockyard. All these are good reasons, from as far as I'm concerned, to accept Dr. Rao's interpretation. So therefore, you had boats, because this was too small for large ships, coming up and going back. And therefore, there must have been some point of transshipment, because Lothal had contacts with the Persian Gulf. This has been shown by some seals in particular. Now, if the Harappans, and we know that the Harappans were trading with, and I mentioned it last time in a different context, with the Persian Gulf, with Central Asia, were they going in their own ships, or were they going in ships coming from those regions? This has been a little debated, but the general consensus among Indian archaeologists at least is that the Harappans must have been constructing their own ships. And as I will show you shortly, a seafaring ship doesn't have to be very, very large. I'll come to that in a minute. A lot of evidence exists on the sea trade that India conducted in the historical period. Now, again, we jump 2,000 years in time, and we come to the time of the Greeks and the Romans, a few centuries BC, and we have this text in the 1st century AD, which is called Periplus of the Erythraean Sea. Erythraean Sea is an ancient Greek name for what we call today the Arabian Sea. And this text was written in colloquial Greek, not classical Greek. It was obviously for use by Greek navigators who were trading in all of this region. So you can see Greece here. And you can see from Rome and from this whole Mediterranean region, you can see now there was of course no Suez Canal, so therefore the boats, the ships rather, had to stop at Alexandria, which was the port city on the Mediterranean, and transship the goods overland and come to the Red Sea, and from the Red Sea then they would travel to all these ports, which are meticulously listed and described in this text, and what each port was trading in, which port was a little difficult of access or even treacherous, and so on. So it's a very, very important testimony of the very brisk trade activity that was occurring in all this region in the first. And as you can see, India's coast is completely dotted with ports. And therefore, ships were coming, ships were going. India was actually exporting a lot more goods than it was importing. It was an economic engine of this whole period with China. But China was largely doing its trade over the Silk Road, though there was a bit of maritime trade also with China through this whole around the whole southeast archipelago. So a very interesting period, and shipping therefore was already quite well practiced. Some Roman authors refer specifically to the discovery of the monsoon winds, because they were very keen to come to India. And Romans imported a lot of things from India, jewelry, spices, timber. Teak timber was very precious to them, because much of the Roman navy was built with Indian teak timber, because teak would resist seawater much better than a lot of other timber. So anyway, they were very keen to travel to India, and initially they had a long and fairly painful travel hugging the coast all along. But at some point they discovered, or somebody, and it is assumed that it was an Indian sailor, taught them the use of the monsoon wind, which allowed them to cross the Arabian Sea and not follow the coast. And this considerably shortened their journey. So in India itself, we have enough evidence of ship making. Again, not much archaeological evidence, unfortunately. A few very limited things here and there. But you can see here at Ajanta, so these paintings are almost 2,000 years old, maybe 1,800 years old. You can see on the left this seafaring ship. So this will have a completely different type of shell from the flat-bottomed river boat, right? And you can see the 3 masts and 3 sails, therefore. So this is definitely a major step in ship technology. You can see there is this front sail, which I believe serves to stabilize the whole ship. And then you have those 2 big kind of rowing things, which are actually the rudders, which steer the ship. So this is at Ajanta. These are not genuine colors. I added them one day for some textbook. The colors at Ajanta are completely different. I don't know what they are. On the right is a coin from the Shatavahana, so that's a few centuries AD, about 500 or 600 years AD. And again, you see a ship with 2 masts and some kind of a rudder at the rightmost point. Actually the design, no, actually the rudders are here. And they match very well these 2. So this may be a small sail corresponding to this one. So there are many more such pieces of evidence, depictions in temples. This is another one from Orissa, but this is a road. It is not wind-driven. Basically, there are many types of ships and boats as per requirements. And this is another example from Puri. But this is much more, this is obviously for some royal event, but actually this is a river boat which is not very different from the Harappan boats. There is a central cabin and there is a high raised side, which was also the case. If I go back quickly, you will see that here also this river boat has a central cabin and high raised sides, and these are the rudders which will allow to steer the boat. So there is this design itself has kind of survived, as you can see. Now, and more of them. This is a sketch of a small seafaring boat, and I think at this point I want to show you a short video, and this is Jumping in Time, a European painting of the city of Calicut in the 16th century, when the Europeans are beginning to come back after the Roman Empire collapsed. There was a kind of a break in the contact with India. Europe was no longer in touch with India for quite a few centuries, and then in the 15th, 16th century, those contacts resumed. So here you see ships of quite a few nationalities. They could be Portuguese, they could be Dutch, etc., and but they could also be Indian. And what's very interesting is this. To me, the more interesting part is here. This is a shipbuilding yard. And at this point, I want to interrupt the slides and show you something filmed a few years ago, about 15 years ago, by a team of French filmmakers, and 38, yes. And this is filmed here in Kutch, in Gujarat. And what you see...
And they are built entirely of wood, an unusual achievement in the modern world of today.
Is a shipbuilding yard.
The shipyards are run by Muslim families. They are descendants of a long tradition of Arab shipowners who landed here on the Indian coast centuries ago.
Why is it not?
And they are built entirely of wood, an unusual achievement in the modern world of today.
So, these are built in a completely traditional method. It's basically a Muslim
shipyards are run by
there.
Muslim families. They are descendants of a long tradition of Arab shipowners who landed here on the Indian coast centuries ago.
I was born here, and so was my father and my grandfather before him. We have always worked in the shipbuilding business. I began at the age of 15 as a simple carpenter under the orders of an owner. He was very pleased with my work, and very soon he put me in charge of the construction of a boat. My first dough was a 200-tonner. I did a good job on it, and I was very pleased for him. We have always worked in the shipbuilding business. I began at the age of 15. Was a 200.
They are all in one way or another involved in shipbuilding. The oldest, Kasim, retired. Shameen's grandfather has asked him to keep an eye on one of the family's boatyards and to meet the architect. The Abad family alone owns more than 25 towers. The new generation of ship owners like Shameen today combines the age-old tradition of marine carpenters with modern developments in the present-day maritime trade. A 17th century shipowner wouldn't feel out of place in Salaya. Although 4 centuries have gone by, he wouldn't see many changes in the techniques which are used to build the towers. Apart from a few chainsaws and some electric saws, no other mechanical tool is used for the building of these boats.
So I will not show the whole film. It's though I will try to share it if with Devar's help we can edit it out of this long film. And what I want to say is that, as the commentator has just said, very, very few modern tools are used. Of course, now they are introducing some mechanical saws and so on, but this is more recent. Basically, this is the traditional shipbuilding in India. They say that they learned it from the Arabs several centuries ago. It's quite possible, or it's possible that it could be older. And what's very interesting is that those ships, and you saw the size in the background, they are of quite respectable size, are very cheap. What I calculated from this is that about 15 years ago, the cost of one such ship was about 70 lakhs of rupees. If you want to buy a steel-made, a metal ship, modern one, is going to run into many crores of the same size. So that is why this trade is still, this shipbuilding activity has not passed out. In fact, they are saying towards the end of the commentary that they are getting more and more orders. It's not as if it's going down. At least 15 years ago when this film was shot, they were actually expanding their activities. And what do they do with these ships? They sell them to traders who cross the Arabian Sea and go to the eastern coast of Africa, which was in touch with India already 2,000 years ago. There's plenty of evidence for this. And they trade in spices mainly and some luxury items, which are exactly the same goods that were traded also 2,000 years ago. So I thought this was very interesting. Now, we will move on with, I have half an hour. This will be sufficient to deal with a few other miscellaneous technologies, which we don't usually get to think about much. One is writing. India is a place, as you know, of huge literature. We constantly speak of our texts, but we don't often wonder how they were written and preserved. Of course, a few texts, like the Vedas, were preserved orally, purely through memory. They could have been written, they were written down at some point. I'll show you one example, in fact. But they were not meant to be written down. They were meant to be memorized. But that's the smaller part. The larger part, texts like long religious texts, or texts like Mahabharata, or other long pieces of literature, or technical texts, etc. They were all meant to be written. So how do you do that? Well, initially, materials were used like the various barks of trees, and the birch tree was found to be very appropriate. So I'll show you here on the left. You have a typical example where ink will be used with usually a brush. It's almost painting, in fact. And this is from the 17th century. Usually those manuscripts will not be preserved for much more than 500 years. This is regarded as the maximum lifetime, or shelf life, if you want, of such manuscripts. But it all depends on the climate, precise climate, location, and the way the manuscript has been stored. A few pieces of manuscripts of even 1,000 years still exist in India. The ink was made of charcoal powder, which was very finely ground and mixed in a kind of gum, which gave it a certain texture, but also very simple carbon, pure carbon, which is generated by an oil lamp, for example. If you have an oil lamp and you put a lid over it, it will not burn cleanly. It will generate a lot of black smoke, which is what you want in that case. And you will collect this on the lid, and then you can scrape it off, and you can get a very good quality of ink. So on the right, on the other hand, you have palm leaf manuscripts. And palm leaves were easier to make and more abundant than birch barks. And they could also be made into much longer pieces. So you have some of them are very small. You have palm leaf manuscripts which are no bigger than this, but some of them can be quite huge. But however, you do not use ink on a palm leaf. You can't, because the texture of the surface of the leaf will not allow you. What you do is that you have actually a sharp metal, typically iron point. And you, with this stylus, as it is called, you actually break the membrane, the upper membrane of the palm leaf. You break it, and you keep breaking it. And therefore, by the way, the motion of the hand precludes very complex letters like what you have in Devanagari with a lot of square angles. Devanagari has a lot of square angles. South Indian scripts are more roundish by appearance, and palm leaf is more suitable to write this kind of script. You can't easily do Devanagari on a palm leaf manuscript. I mean, with a lot of effort you could, but it's not suitable. And then what they will do is that after breaking the membrane, they will smear the palm leaf with typically charcoal powder again. And so it will go into the cuts which you have made. And then they will simply wipe clean the rest of the surface. And then what you have cut will keep a little of this carbon powder, and it will stand out in black on the background. And then there are all kinds of techniques to preserve those manuscripts. For example, lemongrass oil will be applied every few years. But there are also other techniques to preserve them from insects. All kinds of spices can be used in the process. In fact, the Saraswati Mahal Library in Tamil Nadu has a manuscript on how to preserve manuscripts. There's an ancient text on the preservation of manuscripts themselves. So therefore, it is not something that they were doing casually or lightly. They took very seriously those techniques, and they preserved the manuscript as long as possible. But because the shelf life was not more than a few centuries, there was therefore a tradition of rewriting, recopying the manuscripts. And every few hundred years, all manuscripts had to be rewritten. So this meant that the families, the communities that did that, had to be well versed in the ancient scripts. And since the ancient scripts stopped being learned during British times, with the arrival of British education, the tradition was interrupted, and a lot of manuscripts ceased to be recopied, and some of them simply vanished. So anyway, there's a long and very interesting story to be told about this. I'll not go further into detail. I want to mention that paper, which is a different material altogether, because paper is an artificial material. It is something you create out of a cloth fiber, and it is not something that occurs in nature as birch bark or palm leaf. And a paper was, first you have to get the pulp of various vegetal fibers or textiles, and then you will crush this pulp, filter it, and finally shape it into thin sheets, usually with the use of rollers. So China preceded India quite a bit in this. It had paper all the way to the 2nd century CE, where it's only 1,000 years later that paper appears in India. It is usually thought that India learned paper technology from China. It's possible, quite possible, but there is, as often, there is no final answer about this. Excuse me. So this is the earliest paper manuscript that remains. It is in Calcutta. It's of the early 12th century CE, so that's an 800-year-old piece of paper. And this was made from the fibers of a particular plant growing in the hills. You can use a lot of different plants, and Indians experimented with many plants as to which one would give a fiber that could be best worked into paper. And initially, that's very amusing. Do not think that they were cutting paper like something like our notebook. No, since they had traditions of palm leaves, they would create papers exactly with the same shape, and they would create actually things that looked like a palm leaf manuscript, except that it was paper. But then afterwards, innovations in the shapes followed. We have an interesting testimony in 1689 by a British traveler to Surat, which he spells with double T, a voyage to Surat. And he describes that there's a manufacturer in Surat of paper which produces scrolls of paper 3 meters, which is about 10 feet in length, and about 1 foot in width. So these are obviously for scrolls of paper, and he says that they are smooth, slick, and shining. And a few more European travelers testified that Indian papers was of high quality and was actually exported to several countries, including Persia. Quite a lot of goods, Indian goods, were exported in that way. So this tells us that the Indian paper industry in pre-colonial times was doing quite well. But again, with the modern industries coming in, this is a story that you will see with traditional Indian textiles, with traditional Indian iron and steel. Once the modern industries come up in the 19th century, then the traditional manufacturers tended to decline, and this was the case of Indian paper. So this is, excuse me, sorry.
So, you said that the paper...
I'm sorry. I forgot
to... they said that the paper reached the Europe around 8th century. So the paper, how did the paper reach Europe before India? Was it through the Silk Route that the paper reached Europe before India? Like the paper was extensively used in Europe from
when
the 8th
did
century.
paper reach Europe? I think it reached Europe sometime, I will have to check precisely, but sometime in the 12th or 13th century. I do not know whether it was an independent creation or whether, because there was quite a bit of trade with China, so whether Europeans also learnt it from China, we will have to check. I'm not very sure.
And one more thing, sir, all this, when the people were planning cities, they required some kind of writing materials. So even they might have used some writing materials. They could not have used, they could not have done all the calculation.
Writing materials?
Yeah, by the industry.
Where do you mean? Where?
Like planning the cities and...
Oh, so you mean
might
to make, for example, drawings and plans and such things? Yes, quite possibly. The question is that so very few have survived. Now, if you remember the talk by Professor R.N. Iyengar, where he showed, I believe it was he who showed, or was it Arun Menon, one of the two, one manuscript which was published by Alice Boner of the Konark temple. It was a palm leaf manuscript, and you did have a kind of architect's professional drawing of the temple with side view, top view, front view, etc. So it shows us that yes, they were using material to draw out plans, but so very few have survived.
So I was asking about the Indus Valley people. I was asking about the Indus Valley people. They planned the cities. So even did they use any writing material?
At which period do you mean?
And Indus Valley people.
Indus Valley, I'm sorry. There is a little bit of evidence of writing tools in the Indus civilization, pointed rods of copper, and there is a depiction or two of writing, but actually the only writing material that we have is a terracotta model of a wooden plank called the what is it in Hindi? Takti, which was till recently used even in India by school children. It's just a wooden plank with a little hole at the top, and you can hang it on your wall in the evening. And this exists in the early historical period in India. You can find it with, like, there's a statue of a baby learning Brahmi letters with this. But the Harappans have depicted it in a clay miniature. So this much we know, but otherwise, whether they use any kind of other writing material is completely unknown. They might have used cloth, because cloth also was a very simple writing material. Paper, certainly not. That would have been far too advanced for their time. Some bark is possible. That's all we can say. So here you have, from the 19th century, a beautiful manuscript of the Rig Veda, which is written on Indian-made paper. And you see not only the Devanagari in black, but you see the Vedic accents. You know that Vedic texts have to be chanted in a certain way with certain intonations, and they are marked in red. But actually the Veda was not supposed to be written. It was supposed, as I said, to be memorized. Just a quick word on cosmetics, because Indian perfumes were also quite reputed in the ancient world. And the Romans mentioned them as one of their imports, not the main ones. The main ones were, again, jewelry and spices quite a lot, and other food items. But during the medieval times, in the ancient text, you have a lot of references to kings, queens using fragrances, etc. So perfume making is a very old tradition in India. And in fact, we have this text by Varahamihira, which is 6th century AD, about 525. He writes in, I think, 525 or so, his encyclopedia, which is called Brihad Samhita, where he tries to go through all the achievements, or let us say disciplines, fields, including architecture, astrology, medicine, etc., etc. Everything, iconography, construction, town planning, and whatnot. So there is a chapter on cosmetics, and I show it for two reasons. So we know, of course, that the literature refers to all these uses, which you see on the right, for bathing, for hair oil, for even toothsticks. So all of these are mentioned in the literature as using perfumes. But how are these perfumes made? So Varahamihira tells us a method. But there could be, of course, any number of others, where there are 16 fundamental fragrances or scents, which you see listed here, and you can recognize a few of them, like dhanya, like chandana, like karpura, which is camphor, and probably a few more. So these are regarded as the fundamental ones. And then they are mixed in according to various proportions. This is actually combinatorics, and what you see at the bottom is nothing but what mathematicians call a Pascal triangle, except that it is not put in the modern way. But you see how, if you list on the left all the basic fragrances from 1 to 16, you will add them in one portion, two portions, 3 portions, 4 portions, etc. And you go on like this, and you build the Pascal triangle in a way that one box, in one square, the number will be the sum of the neighboring squares or the squares below. So this is how he simply elaborates the series of possible combinations by giving us also an example of his mathematical knowledge. So anyway, this is a thriving technology. The Mughals in particular will make extensive use of perfumes, and if you visit any museum of medieval period objects, whether even the forts of the Rajputs or whatever, if you go to any of these museums, you will always find some very nicely crafted perfume bottles, or to keep the scents. So this is very, very common in India. One more technology, and perhaps the last I have thought of for today, is ice making. Now, ice making seems like a paradox, because you might think that either you have a freezer or you don't. If you don't have a freezer, how can you make ice? So you can make ice, of course, if the weather is freezing. That is so obvious that we don't have to discuss it. But even if the weather is not freezing, you can make ice, provided it's pretty cold. And you can make ice by using a simple phenomenon that when you have water that evaporates at the surface of the water will have a temperature drop. This is something that in thermodynamics, for those of you who have studied, you should remember. If you have some evaporation, not caused by heating, of course, not that you are heating the water, if there is some evaporation, the water temperature will drop. And in fact, this is why people love to keep water in a clay pot, right? Because the porosity of the clay will cause some of the water to evaporate through your clay, and this will cause a temperature drop. So you will have a cooler, it's a very simple cooling device for your water. Of course, within certain limits. Now, the Mughals were not only fond of perfumes, they were fond of all luxuries, and they were fond of sherbets with ice. You know, this, and we can understand, of course, in the Indian summer. So how do you have ice in Indian summer? It sounds totally impossible. Well, it's not. If you have taken care to harvest enough ice during the winter, but also as late as possible in the winter, and this is done by this device, which is described here by a French traveler to India, Le Jour de Flay, where he says that how is it done? It is done in cold regions, but not freezing, where what you do in the countryside, you dig a big pit, you see, which has raised sides, and you fill it with 4 or 5 feet of straw. And I believe the role of the straw is to provide some air insulation, so that the whatever temperature drop happens will be confined to the area. This is my understanding. But I have not made a deep study of this, so somebody should do it. And then they will have very flat, because it's only 3 to 4 inches deep, very flat, broad plates where they will put water. And then this happens during the night. There is, of course, a temperature drop during the night, but then the water evaporating a little bit will cause the water surface to have a few degrees drop, and if you are just a few degrees above freezing point, this will be enough for the rest of the water in your dish to freeze. And then the sheets of ice are harvested and stored and stacked up. And what the Mughals did was that they had ice chambers in many of their palaces or forts. There would be a heavily insulated ice chamber, which would be usually in the lower levels or even underground. And then they would accumulate hundreds of kilos of ice in the winter or as late as possible through such devices. And this would become effectively a cold chamber. And because of the insulation, they would use straw in particular again. This would ensure that this lasts as long as possible into this summer. So it is possible. I'm not aware of anybody having worked out exactly, the quantification of all of this. It would be interesting as a project to do. But this is what the literature tells us, and the testimonies of such travelers confirms. So, I have one other for our eminent earthquake engineer present with us today, which is, did Indians develop, and this is the last technology I will discuss, did ancient India develop earthquake-resistant structures, which of course is a great concern in modern civil engineering. I'm giving you just two pieces of evidence because there are no texts to my knowledge describing, of course there are texts of construction, but the concept of earthquakes-resistant building is not discussed explicitly. However, when we visited, I should have given you a broader view of this reservoir in Dhoravira on the left. It's a huge reservoir just below the castle. It's called the East Reservoir because it's on the eastern side of the castle. And it's about 73 meters in length and something like 33 meters in width. So it's quite huge. It can contain millions of cubic meters of water. It was fed by some seasonal small streams whose water was diverted into the city by a series of dams. And as you can see, the walls of this reservoir are built with stone. And there was some mortar, which was basically a mud or a limestone mortar, one of the two. But then when I visited this site it was my first visit to Dhoravira in 2009 in company with Professor Aranayenga, who lectured in this course. I hope you remember him. And also in company of Dr. Bisht, the excavator who directed the excavations in the 1990s. We noticed that strangely, the wall of this reservoir had these two vertical lines where obviously the stones are no longer interlocked as they are elsewhere in the wall. So I asked Dr. Bish first question always to ask in this case, is it a modern restoration or is it the original ancient wall? He said, no, this is the original ancient wall. We have not restored it. Okay. So it was built like this. So then why? I said, why do they have this? And it was Professor Iyengar who said that in his view, and he's an eminent civil engineer, as you know, this is what is technically called a fuse. What is a fuse? It's the weakest part of an electrical circuit, right? If anything has to blow, it has to blow there. So he said technically this is known as a fuse in the sense that if you have an earthquake and the whole wall is going to shake, this part is independent. It can be ejected or it can fall off without the rest of the wall necessarily collapsing again. If the whole wall is interlocked, then there is a danger that a larger portion of the wall may collapse in the process. Now, I do not know whether this is a genuine explanation. Again, we would have to do perhaps some modeling of such a wall and see through some software exactly what happens. Or is it that there was a collapse and the Harappans found it easier to rebuild the wall just like this? What Dr. Bish added is that the same feature occurs in the fortification walls of the castle at several places. But these were no longer quite visible to the visitor. So unfortunately, we don't have a proper study of this, how many such so-called fuses, if there were fuses, were there. But it's intriguing. It's intriguing. Now, there is a better documented traditional way of constructing in the Himalayas, which is, as you know, an earthquake-prone area where a lot of powerful earthquakes occur. A traditional method of limiting the damage, if you are going to have what exists in most parts of rural India, simple rubble walls. You just take stones of any shape, you can build them into a proper wall, have some mud plaster, and you can construct a house. This is the most dangerous structure in case of earthquakes. This is what collapses immediately because it has no structural strength. So in many parts of the Himalayas, and this is in Uttaranchal, which is now Uttarakhand. I'm sorry, I should have updated my slide. In Uttarakhand, this was documented. We have a technical paper on this. what they have done is that they have used these timber beams to girdle the structure at several levels so that this kind of holds it together, and if there is going to be some lateral motion, a rubble wall will immediately give way, but this will have some structural strength and it may not collapse immediately. And this was actually witnessed in actual earthquakes. And obviously this is the result of a long observation of earthquakes and how to build structures that hopefully will resist. And this was actually witnessed in some earthquakes, and we have documentation for this. So this is Dr. D.P. Agrawal, who is an eminent archaeologist and student scholar of traditional technologies, who wrote a paper on this. So this was just a few views of a few technologies which we do not fully develop in this course, but I thought it would be an interesting addition. If you have any questions, please don't hesitate. We have a few minutes. What I hope to have shown is that in many different fields, people were quite inventive. And they were able to think about technical challenges, whether it is sanitation, whether it is ice making, all of these technologies, of course, leave alone the major technologies which the rest of the course has dealt with. You find people thinking about the challenges and be able to innovate and come up with some solutions with traditional technologies that after all stood the test of time. So I thought that this was the interesting takeaway from this quick survey.